Hello, I'm Seseshe Magaja from ESL Teacher Juric Tutoring Services. We hope you're well. We'd like to welcome you in our virtual classroom. Today, we're going to be doing chemistry, specifically Charles Law. Now, I'm going to explain Charles Law in a way that you as a parent can understand using this virtual simulation that I'm going to display on my screen. As you can see, we have this screen here, and in this screen, we have a container. The container has a pressure meter, and it also has a thermometer to measure temperature. Now, according to Charles' law, it states that there is a relationship between pressure and temperature. So, the question is, what happens when you increase temperature of a gas inside an enclosed or inside a container? Now, let's see what Charles' law states in a practical way in this experiment. I'm just going to pump in some gas. Now, you will notice that the pressure when there was no gas was 0, but suddenly, as soon as I pump some gas in, it suddenly becomes 11 atmospheric pressure or 12 atmospheric pressure. That's the average. Now, what happens if I decide to increase the temperature from 300 kelvins, let's say, to 2000 kelvins? Let's see what happens. Now, you will notice that the first thing that happens is that the gas inside the container is moving faster. And according to collision theory, when you increase temperature, you're basically giving the gas more energy or more kinetic energy. And the kinetic energy increases, increasing the pressure inside the container, more effective collisions. But we're not going to be doing that now. We just want to see what happens when you increase temperature of a gas inside a container. And you notice that the pressure is slowly increasing. But now if you continue to increase the temperature beyond what the container can hold, the lid was blown away. So now, what conclusion can we make, or what theory can we deduce from what we've just seen? Temperature is directly proportional to pressure. When you increase your temperature, you are increasing the pressure. That is why most aerosol cans, most sprays have a sign that says, do not put on direct fire. Because if you put that container in direct fire, or that aerosol can in direct fire, it will explode, as you've seen in the screen when the lid was blown away due to the high pressure due to the temperature. Now, that was just an example of what would happen when you increase temperature for a gas inside a container. What if you add more particles or more of the gas particles? Think about it. This was just an example of how I teach your child. Imagine the possibilities.